All right, IM2 classes. Today we are talking about how to simplify radicals, and we're going to be solving quadratics using a square root. Radicals are square roots, and we're going to be solving equations with square roots. So it's all about square roots today. So what we're going to be simplifying are square roots that aren't perfect squares. So 72 and 48, those are not perfect squares. In class, I'm going to show you how to do this a little bit quicker, but if you're not good at recognizing the perfect squares, this is a way you should do it. Step one, you're going to expand the number using a factor tree. We've done this many times in class. Um, 72, this splits into 2 times 36. 2 is prime, so that branch is done. 36 is 2 times 18. Again, 2 is prime, so that branch is done. 18 is 2 times 9. 2 is prime, that branch is done. So, and then 9 is 3 times 3. Once we have here, I'm going to put all my prime numbers here. Branches are done, all the prime numbers. I'm going to put them back underneath the radical. All right. And then I'm going to circle buddies. This is called a buddy system. So we look for buddies. They need to be pairs. So I'm going to look for pairs. So I have a pair of twos. So there's three twos, but I'm only going to circle two of them. And for every pair, for every set of buddies, one of those buddies goes on the outside. And I'm going to cross them out there. Right. Then I have a pair of threes. For every pair of buddies, one of those goes on the outside. Cross it out. Once you have done that, then you multiply through what's left over. So I have 3 times 2 on the outside, so that's going to be 6. And then a 2 left on the inside. So 6 square root of 2. All right, so here for 48, 48 would be 2 times 24. 2 is prime, that branch is done. 24 is 2 times 12. 2 is prime, that branch is done. 12 is 2 times 6. Uh, Branch is done. And then 6 is 2 times 3. So I'm going to take all these twos. There's four twos. One, two, three, four. And then one, three. And then I'm going to look for buddies. So there's four twos. So I only two at a time has to be buddies. 2 times 2, or for every pair, one of those goes on the outside. I have another pair of twos, so I have one more 2 on the outside. All right. 2 times 2 is 4, and there's a 3 left on the inside. And there we are done. All right. Next one. So here we have some variables in here, and that's okay. We're going to do the same thing. I'm going to do a factor tree on the number. So 80 is 2 times 40. 2 is prime. That branch is done. 40 is 2 times 20. 20 is 2 times 10. 10 is 2 times 5. So I'm going to put all those numbers back in the radical. So four twos. So one, two, three, four, one, five. Then the variables, I'm going to expand those. So there's x to the third. So that is one, two, three x's getting multiplied. Y to the fourth. One, two, three, four. Now expand everything and search for buddies like we just did. So I'm going to have 2 times 2. So I have a pair of twos. So 2 on the outside. Another pair of twos. So another 2 on the outside. Cross it out. Now I do the same thing with the x's. So there's 3 x's. I have a pair of x's. I'm going to put the x down here. For every pair, one goes on the outside. Um, and then we'll do orange. I have a pair of y's. And then one more pair of Ys. So just find all of the buddies. And for every pair, one of those goes on the outside. Multiply back through. So 2 times 2 is 4. Y times y is y squared. So 4xy squared on the inside or on the outside. And I still have a 5 and an x left on the inside. If there are more numbers left on the inside, then you just multiply those out too. Right? We're going to move on to the next thing, solving by taking the square root. So when we're solving, remember that we are going to be using order of operations backwards. All right. So the square in this case is going to be the last thing we're going to take care of. So we have 9b squared. We need to take care of the 9 first. So I'm going to start off by dividing both sides by 9. Times 9 divided by 9 cancels out. And I'm left with b squared is equal to 100. So b squared, the opposite of squaring something is the square root. So I'm going to take the square root of both sides. So the square and the square root cancel each other out. So the square root of b squared is just b. Square root of 100 is 10. Here's the tricky thing. When you take the square root, you can have two possible solutions. It can be a plus or minus 10. So all of these are going to have two solutions. We're going to talk about it more in class. So B could be positive 10 or it could be negative 10. So to keep the video at a reasonable length, for right now, if you're watching this at home, all you need to remember is when you're solving and you take a square root, you could have two possible solutions, one positive, one negative. All right. And we'll go over it more in class. Here, so same thing. I need to take care of the 6 and the 81 first, and the square is going to be last. So my first step is I'm going to subtract 6 from both sides. Plus 6 minus 6 cancels out. You get 81 n squared is equal to 87 minus 6 is 81. Take care of the 81 on that side. So the opposite of multiplying by 81 is dividing by 81. Times 81 divided by 81. That's going to cancel out on this side. And then we have n squared. 81 divided by 81 is 1. Last step is to take the square root. The square root of n squared is just n. The square and the root cancel each other out. Square root of 1 is 1. And remember, it can be plus or minus. So it can write as positive a1, or it's, two solutions. All right. Um, Here, like we just did on the other ones, if it's not a perfect square, right? When you take the square root, right? 87 is not a perfect square. I need to do a buddy tree on it. So I'm going to do a factor square root of 87. So 87, that's 3 and 29. 3 is prime, so that branch is done. 21 is also prime, so that branch is done. So since if I were to put this back in the square root, 3 times 29, there are no buddies here. There are no partners, so nothing goes on the outside. So I just leave this as the square root of 87. You can't take any buddies. But again, since we took the square root, it could be two solutions, positive root 87 or negative root 87. So my two answers would be n could be square root of 87 or it could be the negative square root of 87. So if you have something that's not a perfect square, and you do a buddy tree and there's no buddies, nothing takes out, you just leave the number as it is. All right. Next here, so let's do this one. So I'm going to take care of the minus 8 first. So I'm going to add 8 to both sides. Minus 8 plus 8 cancels out. You get 6r squared is equal to 552. Then I'm going to divide by 6. Times 6 divided by 6 cancels out. I'm going to use a calculator on this one real quick. 552 divided by 6 comes out to 92. So R is equal to 92. Oh, R squared, excuse me. Last step is to take the square root. 92. So that's not a perfect square, so I need to do a buddy system on it. What the heck just happened? 92. That goes 2 times 46. 2 is prime, that branch is done. 46 is 2 times 23. So if I have Put those back in the radical. 2 times 2 times 23. I have a pair of twos. For every pair, one goes on the outside. So it is 2 root 23. So the square and the square root cancel each other out. I just have r square root of 92 is 2 times the square root of 23. And it is plus or minus. Don't forget the plus or minus at the end. So my two possible solutions are positive 2 root 23 and negative 2 root 23. All right. So here's a little bit different. I need to take care of the square first on this one. So x minus 2 squared, I need to square root both sides first. I can't, to get inside the parentheses, I got to do the square root. So I have x minus 2. The square and the square root cancel each other out. And then square root of 9, that is a perfect square. So that's going to be plus or minus 3. Here's where this one is tricky. Since it is plus or minus 3, I have to separate out that plus or minus. So this actually gets split into two equations now. I have x minus 2 could be equal to a positive 3, or x minus 2 could be equal to a negative 3. Now I can continue solving on each of these. I'm going to add 2 to both sides. You get x is equal to 5 on this one. Or I'm going to add 2 over here. You get x is equal to negative 1. So I have two solutions. A little bit tricky. Make sure once you get that plus or minus, you split it up. All right. Next one. Uh, we're actually going to skip to this one, what to do if it's not a perfect square. So here, first step I need to do is take care of the square root. Square root of 21. 21, I need to do a factor tree on that. 21 splits into 3 times 7. 3 is prime, that branch is done. 7 is also prime, so that branch is done. Since that there are no buddies, if I put that back in, no pairs, this stays as plus or minus the square root of 21. Can't simplify it anymore. So x minus 10. Uh, and so here, again, I need to separate out my two possible solutions. It's going to separate into two equations. So it'll be x minus 10 is equal to positive root 21, or x minus 10 is equal to negative root 21. All right, and now I can continue solving. On this one, I'm going to add 10 to both sides. Um, So minus 10 plus 10 cancels out. You get x is equal to, I can't add the 10 to the 21 because that 21 is in the radical. It's being protected by that root. So I just have to leave it as 10. I like to put the 10 in front. 10 plus the square root of 21. It's a positive 10. I put it in front. You can do root 21 plus 10. It doesn't matter, but this looks nicer when the number without the radical is in front. So this one, I'm going to do the same thing. All right. Uh, minus 10 plus 10 cancels out. And then I have x is equal to, I'm going to put the positive 10 first, minus 21. Again, I can't combine the, I can't combine the 10 and the minus 21 or the 21 in there because that 21 is protected by the radical. All right. Um, that will do it for now. We're going to practice this more in class. We'll see you guys next time where we're going to be graphing quadratic equations and solving them.